Hello everyone. Welcome back to Python Challenge for All. Okay, let's see where we were last time.
So last time we lesson 50. Oh, it was lesson 50. Click the bouncing ball one. So we in lesson 49 made we implemented so that the ball bounces on the wall. And then last time, in lesson 50, we learned how to click the ball, click with mouse, and just decide whether it is in the ball or not. Okay, so it was, let's see the code. So it was here. Yeah, so if mouse is clicked, the left button is clicked, you can find out the mouse position by this one, like this way, mx and my, and then by comparing the distance to the center, meaning distance to the center, difference of x coordinate squared plus y coordinate squared. That's square, and compare it with the square of the radius. And if it is the distance is smaller, it means it is in the circle, in the ball. So then, yeah, we tentatively change colors from 1 to 0 to 14, okay? And make the background 15. Okay, so let's see. Was too much. Okay, so maybe as the homework says, changing 4 colors at each click. So let's see. Another way is to implement that is say colors, make a color list, which is like I for I in range. Say which 4 colors shall we use? Let's see here. Let's use 0, 1, 2, 3. Okay. So range 4. So this will, as you know, make a list starting from 0 to 3, right? 0, 1, 2, 3. So then we can use, say, color index. Instead of using color index, initialize the 0, and then increment color index by 1, and then color is, say, color L equals color L self color index. So this will make the 4 colors. Okay, let's make a little ball a little smaller, like 15. And let's run it. Okay, something is wrong. Self color. Okay, self color. I see. Okay, so let's make this here too. Okay, let's run it. Okay, black, blue, dark blue, purple, and back to, oops, I forgot to make it percent, percent, say length color L. This is important because we want to have a modulo by the length of this list. Okay, so so maybe it's fine now. Okay, so today it's good. Okay, so let's move on to today's work. Try out more variations. Like, let's see, change the frame per second value to 30 and see the difference. Okay, instead of maybe we cannot tell the difference. Okay, now of course it's faster, so we might want to change the initial speed down to half of it. Let's see how it looks like. Okay, good. Okay, fine. So maybe we can know that the mouse can be moved smoothly because the frame rate is faster. Okay, that's the difference. And the ball is running smoothly too. Randomize the initial velocity. So the point is now the initial velocity is fixed to something like this. So let's make it also randomized. So let's see, one thing I want you to remember is that using random, okay, actually random, the same function is in Pyxel, but let's use the more general library, random. So random, one thing we need to remember is that random returns a kind of uniform random variable, random number between 0 and 1. Okay, so if you say multiply it by say 3, 4, and divide by 2 and subtract 2 from it, will make the speed in the range of -2, between -2 to +2. Okay, so this would be somewhat randomized initial speed. And the same for V component. Let's see how it looks like. Okay, so it's like this. Okay, let's run it again. Okay, this time it's running this way. Okay, good. What's next? Okay. So one thing I want you to remember here is random generates a random, uniformly random variable, random number between 0 and 1. So you have to multiply and then subtract something to make it in the more applicable floating number. Okay, reduce the radius gradually. So it's more like an interesting game. So to make it more challenging, we can make the ball shrink at each time frame. So for example, here, we can recalculate. For example, how about each time? Let's make the ball 1% smaller. You understand what it means? The initial size is 15, and in every frame, like one, 1/30 seconds, 33 milliseconds. No, 33 milliseconds, it becomes 1% smaller. Let's see how it looks like. Is it too fast? Okay, like this. Okay. Ooh, becoming smaller and becoming harder to click. Okay, like that. Good. Interesting. Emerge at a random position after the ball disappears. So it seems at certain point, the ball disappears, right? Let's see, naturally, or it becomes difficult to see. Okay, so maybe now it's almost impossible to click. Okay, so maybe we can make it. Once it becomes too small to click, uh, let's pop up at some position with some random speed, um, so that we can do the click again. So maybe here, maybe we can do that. If self.r is less than, say, 1, okay? Then what we need to do is like this. Let's copy it, paste it, and uh, oops, sorry. Let's how about, okay, like this tab, okay? And also we want to randomize the position, initial position. So to do that, size is can x times can y. So maybe we can use rand int in the size of 0 to scan x. Maybe it's too big, but it's okay. Can y. I think this is good enough. Just to make sure, let's make it a little bigger, or as for the horizontal size. Let's see how it looks like and see. Fix it if it's not. Okay, becoming smaller, click, smaller, and small. Okay, now it's too small. Ah! Speed is too fast. What is the problem? Okay, round hints. I think it is good enough. What's the problem? I see. Round should be also initialized. So R should be initialized as, okay, something like from 10 to 20. How about this? Random number between 10 and 20 inclusive. Small, 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 small. Okay, let's change color. No. It's when it's small. Random. I misspelled it. Okay, sorry. R. And also, let's make it below 2. So that's, we can check that earlier. So it becomes smaller, shrinks, shrinks, shrinks. Okay, so this reappears, emerges somewhere else with the same color but different size, different initial velocity, different position. Yeah, okay. So I hope you like this. You can make this kind of changes as you like. So today I showed some of the possible variations you might think of. Okay, this was interesting, right? Becomes smaller, shrinks each time, and if it becomes below a threshold of 2, it reborn. It becomes emerges at somewhere else with the initial randomized initial speed, random position, and random size. Okay, I think I've shown you several examples, so you can try yourself your variations too. Next time, maybe think about gaining a score. Okay, so initialize a score as 0, and then every time you successfully hit the ball, increment a score by certain point, which is, for example, larger if the ball is smaller or if the ball is moving faster. Like that, okay? So try yourself and enjoy. That's the most important thing. Please enjoy programming. Okay, come back next time. That's all for today. Thank you. Bye bye.